This is the InfoSec and Notes Show, episode 76. I'm your host, Josh Amishav. Today, we're going to talk about attack surface management with Chris Dale. Chris is the founder of River Security as well as a SANS instructor. My three main takeaways from conversation were: one, how to generate a custom word list for brute forcing your target; two, a bunch of methods to correlate associated company assets via things like DOM, JARM, and TLS; and three, how to automate the vulnerability discovery process. You'll enjoy those three things plus a bunch of other ear nuggets along the way. And now, here's my conversation with Chris. Chris Dale, welcome to the show.
Hey, Josh. Thank you very much. Nice to be here.
Great to have you back on the show. You're the first guest for this make a second time appearance.
Awesome. Well, I'm honored to be here. I listen to the show regularly, and it's one of my favorite podcasts. So that's cool.
Awesome. Okay, so I was actually interviewed on a podcast a couple of weeks ago, and the host of the podcast asked me if I see AI taking a position in pen testing, and my response was, actually, we don't really need AI at this point because there's so many assets that people don't know about or passwords that people are reusing that we don't really need anything beyond that. Where do you see asset inventory place in pen testing today?
So there's definitively room for AI and machine learning to help attribution of assets, being able to identify, for example, a server belongs to a given company or not, to consider if it should be in scope or not. This would apply more to the larger Fortune 1000, Fortune 10,000 companies that are very diverse. They have lots of subsidiaries and companies underneath them, where attribution of assets can actually be quite hard, to be honest. What to attack, what not to attack, what to ask our customers for, if it's in scope or not.
So what are the, we briefly talked before the show about JARM, and that seems to be like a pretty cool technology that can be used to help attribute certain assets to a company. How does JARM work?
So the nice thing about JARM is that it allows us to fingerprint the SSL TLS configuration, and how basically allows us to differentiate between, say, for example, one customer and another. It's JARM developed by Salesforce. It allows Salesforce to identify servers that are using the SSL TLS configuration and certificates of Salesforce, contrary to, for example, a certificate and SSL TLS configuration that identifies as, say, Google or somebody else. But JARM is just one player out of many factors that we can use to attribute a given asset to a company. There are things like, for example, having the same robots.txt that would grade the assets more likely towards being the same as another assets, having the same mail exchange, having the same name server, having the same lots of attributes will basically allow us to say, with a likelihood of, say, 95%, we believe this is the asset of the customer. And that is really useful, especially when scanning cloud assets and scanning huge ranges of assets with, say, mass scan and so on.
No, so the robots TXT, that's an interesting push. I think the mail server would have been really useful about 10, 15 years ago. But now when there's like consolidation of lots of players using Google or Microsoft's, what are they?
Sure.
Yeah, so that seems a little bit less effective. What are the other attributes that you find to be pretty good indicator? Like we used to have who is information. You can do reverse who's lookup, and now with privacy is the default. That kind of that technique also is kind of dried up.
Yeah, we have a spreadsheet of basically where we built a Python script surrounding some machine learning surrounding this. All the attributes, I don't have them on the top of my head right now. But for example, one of the things that I did come up with was the ability to take, say, a website and look at the DOM and compare the DOM, not the contents, not the inner text of HTML elements, but if you compare the DOM against one site against another, machine learning can give you a little bit of ratio. How similar is this system towards another system? And these are not definitive answers, right? These are not something that I wouldn't use this in a fully automated fashion, but these are attributes that helps, say, a pen tester or a security analyst to say something about this assets, how likely it is to be a part of the configuration that you are allowed to attack.
How would the DOM work? You're looking at like variable names, you're looking at like indentation, or what kind of attributes are you looking at there?
Yeah, and the vendors know about this. This is kind of getting annoying, but yeah, we're looking at the DOM, how the DOM is built up. So the document object model, which elements are in place, any custom elements, and so on. These things would basically help attribute if this is the same system as another system. Which elements are in use, how the buildup is, paragraphs versus divs versus so on and so. But and also class names, CSS, and so on. However, say for example, Facebook, they randomize their DOM now. They will make their entire document object model fully randomized, making it makes it different to if you don't use a proper machine learning algorithm. It's very different and cumbersome to try to fingerprint that DOM to look for similar DOMs.
Okay, and I'm just curious if multiple companies are using, I don't know, say something like Bootstrap or using the same software libraries, they're going to have identical names within the DOM as well, which make it more difficult to use as a technique, right?
Sure. So it's still just an attribute. It's something that helps assess the situation. And you could, for example, if you want to go all the way to the basics, if you have a host name that is pointing to the same IP address, the IP address has been attributed to the customer, you could probably say that other host name, that other website is belonging in the same cluster of configuration, same cluster of systems that are attackable, right? Like a shared host. But that would be a strong attribution. But say the DOM, in some cases we can have a quite strong attribution from the DOM. But say with Bootstrap, jQuery, like with other types of frameworks and libraries in use, the significance is lowered, the value is lowered, but it's not worthless, and it's still quite valuable, to be honest. And even if you do use Bootstrap, how you use Bootstrap, which elements of Bootstrap you're using, and so on, these things will still help us differentiate. But this is actually, so what I'm talking about here is we're talking about attribution. In our case, we've kind of, we build this metadata surrounding domains and assets that we identify, but we actually have a human element in place here. We don't rely on automation. We do semi-automation. So we build up a lot of huge data sets in air quotes, a data lake. So basically our bunch of databases. But we build up a lot of metadata, and we let a technical account manager / security analyst manually confirm if this asset is in scope for pen testing or not. And that really helps us. It makes us stronger, but it's also, of course, a bottleneck in terms of how many customers we can onboard and so on. But we definitively believe that the quality gets higher.
Yeah, definitely. When you've got a hybrid of manual and automated means to do that. Just remind me, I was doing a pen test a while back, and actually one of the ways we found I was able to attribute one website to another was actually looking at the privacy policy, which is some mundane, but yeah, another great one. And then one of the other ones that I find very useful, and I imagine everyone's doing this at this point, is just comparing tags like Google Tag Manager.
Yep.
And creating database. Now, are you creating your own database or using third-party databases for that?
We are using a combination between document storage and relationship database management systems. By the way, in regards to the Google tags and tag managers or like tags, there is a Nmap NSE script for exactly that. I believe it was written by Robin Wood, DigiNinja. So there's a little script that will help you figure out if there's a reuse of tags across multiple websites that you're scanning. The privacy policy, I had to write that down. That's beautiful.
I'm glad that helped. Yeah, the other thing that I found, I wasn't aware of that the NSC script, because I've been always using builtwith.com has a API, or not an API, you can manually look it up via their website and just kind of put it in that way, and then you can map out, and it makes it easy to pivot off, because if you look up one domain, you'll see all the tags they have, and then you can easily pivot off. Are there other places you use to do that?
Yes. So we also use BuiltWith, but we also use Wapalizer, and we also have our custom scripts. We call them collectors. So what we try to do at least, is that we try to build as much horizontally as possible, as many scripts as we can to collect some sort of data. So for example, Wapalizer, BuiltWith, custom collector scripts for, say, a privacy policy and so on. We'll build all of these tiny collectors like microservices, and these will be just fed into a REST API that will store it in our backend. Then on top of our backend, we have an API gateway through GraphQL that sort of normalizes or stitches all of the individual piece of information that we find. So say, for example, for a domain, we stitch a bunch of different collectors. All of that information we stitch together to return one type of entity, which the pen tester can look at. It can look at the attribution, it can look at its values, and we can also now automate collection towards that specific entity. So we have entities such as, for example, domains, IP addresses, repositories. So we have Bitbucket collectors, we have GitHub collectors, we have an entity type called, say, a user, where we use BreachSense, for example. BreachSense, we ask BreachSense, your company, your little API, we ask BreachSense, hey, what can you tell us about this domain? And if we find any user on a domain with leaks on it, we also consolidate or normalize that information into a user entity so that we now know that we have a user that can be attacked in different vectors. It can be used for phishing, it can be used for logons, password spraying, and so on. And all sorts of entities. We have like 8 or 9 entities, like mobile applications, vulnerabilities. We have word lists even. So we use Cool. We use information from a company's company name, and we use information about all the word lists that we generate with Cool, obviously, and the subdomains of each company that we have identified. These turn into a word list that we will use for password spraying, subdomain enumeration, and so on.
Okay, let's just dig down into Cool to generate the word list. So essentially, if I understand correctly, you're scanning the website using Cool, and then that generates the most popular words that are used on that, and then you use that for the DNS enumeration. Is that right?
Yeah, that's the ABC. Yeah, sure. And we have a lot more complexity on top of that. We allow the pen testers to download those word lists as a CSV, as a text, and so on, and apply them in different fashions and attacks that we would like to as well. But in general, yeah, Cool, among other things, we use to automate other processes that require word lists. So we collect PDFs and metadata and the Cool data and so on.
Okay. Just out of curiosity, what's the effectiveness of using like a Cool-based word list as opposed to using something from like a SecList, one of those word lists?
Yeah, SecList, Daniel Meister's repository is great. But what I've noticed is that the ones who are winning the bug bounty game, if we were to say, is the ones that have the most specialized word lists. It's the ones that have the best recon process. And the more specialized you can become, the more highly successful you are. Well, it's not successful in every case. In some cases, we do see customers, for example, deploy servers where the name of the server is something from their product portfolio, something from a white paper, something that makes sense to the company alone, which isn't a part of the SecList repository of words and so on. So having those customized words that we collect from the websites then allows us to at least be able to identify them. Keep in mind also, Josh, we actually wash away junk words. So when we collect with Cool, we wash away all that junk, normal English words and so on. That gets washed away, so we don't store all the junk.
Okay, yeah, that's important. Otherwise, you end up with a lot of extra words that aren't going to be relevant.
We actually use the Scrabble word list to one of the word lists we use is a Scrabble word list for English words to clean up the existing word list from the website that we generate words from.
Okay. Do you do a lot of pen tests in non-English speaking countries?
Yeah, actually. So my company is primarily based in Norway. So we have a lot of Norwegian customers, Swedish, Danish, and so on. And also surrounding in Europe, there's the English language is typically second language.
So how does that work with brute forcing word lists?
Yeah, it makes them much stronger, obviously, because now from their websites, we'll get those words that we won't necessarily have in a English word list set. Although we do collect word lists in different languages, being able to use Cool to generate a custom word list, that's amazing. But we obviously won't be able to wash away English words from a foreign speaking website, right? So
yeah, and then do you end up with like inflated list, or do you have is there like other countries where like the equivalent of a Scrabble word list that you can do to clean them out?
So right now that is not implemented yet. So you could say we have a bloated backend with too many words, but it's not that much, to be honest. It's acceptable. However, in my product repositories that we use for pen testing, we actually have a folder within our word list repository containing words from a lot of non-English speaking foreign countries. So that's something that we might be able to implement in a later game. Identify these words, what language is it, and then clean with a word list that is specific for that language. But not on the roadmap right now, no.
Cool. Now, you're doing internet-wide scans to collect all this data all the time, right?
Yeah, on some portions, yes. In the cloud, we scan the public IP space of cloud vendors. However, for other things, we try to look at the low-hanging fruits that give us the most value. For example, a big one is using the not the certificate revocation list, but the certificate transparency log, which is just amazing, right? You just get like a live feed of whenever somebody creates a new certificate. And I envision companies are going to start using wildcard certificates more in the future, just to get that little bit of security by obscurity to prevent new domains from being immediately attacked by pen testers and also threat actors from the outside.
Are you querying the CRTSH website like to query, or do you grab it from somewhere else?
No, we have a custom implementation, a Python script, not very high performing. It does drain a lot of our CPU on the instance that we're running it on. But we have a custom implementation that is just feeding off that constant log immediately and gives us a push notification in our project that something has happened, something new has developed.
Okay, but you're not, in terms of like when you're gathering, what we talked about before, gathering, let's say, the robots.txt files, in order to be able to figure out other assets that belong to the same company, you'd have to be scanning every robots.txt in the world. Or do you use like something like Showdown for that?
Yeah, so the thing is, we don't scan absolutely everything. We buy, for example, access to Google to be able to search through their APIs. And when we get results, we want to verify and easily vet those results ASAP. So instead of scanning absolutely everything, which some companies are doing, we scan in a more targeted fashion. Very like we're looking for keywords, we're looking for the customer logo, for example, we're looking for their little brand name and so on. And we look for their company names through search engines, through API providers, OSINT databases, and so on. And those assets we want to quickly be able to attribute if they belong to our customer or not, to reduce the manual labor it takes to attribute, basically.
Okay, that makes sense. And then the other big plus side is by avoiding doing internet-wide scans, you're not going to be blocked by a lot of the other vendors that...
Sure. Yeah, blocking is definitely something that's on our radar that we're paying attention to. Another quick heads up, though, Josh, is that the nice thing about being on the white hat side of things is that if you have the necessary backend, you can open up APIs to your customers. So for example, when they update their DNS server, when they have something provisioned in the cloud, they can also tell you about those updates. So they can kind of let one security team to another, let each one another know about the changes so that we can become the first one to test the system. Because that's what we're trying to do. I mean, with the whole game of attack surface management, it all boils down to being the first one to assess risk. And we call these things, you might have heard of the OODA loops, being able to observe, orient, decide, and act the quickest and the most times a day. The people with the fastest OODA loop will typically win the game in cyber.
Definitely. And that definitely works when the company is aware of their assets.
Yeah.
I think the major problem we're having today, though, is especially for medium to large companies, is they don't know what they own and they can't tell you when they add something new. And then in which case the entire internet then can run the same type of monitoring that you're doing and then start pen testing or bug bounty hunting or attacking beforehand.
Yeah, everything is nice if you think about the things you know about, but you have to expect the unexpected. Developers are going to set up a new subscription in Azure or in Amazon. They're going to try out the Alibaba cloud. They're going to provision services that are outside of your control. There's shadow IT and dark data left and right. And we just have to accept the fact that those things will happen, even if we're trying to get that full control. We still have to look for that data and those assets. for sure.
Now, when you're relying on like companies that say, like you mentioned, like Google API, do you have any visibility into the lag time between when the asset first comes online to when it gets picked up by one of those scanners?
Yeah, as this is very variable results, but some of the APIs and OSINT databases that we've been using, for example, TinEye, you probably know the reverse image searching for TinEye. It was very disappointing that the speed it took them to basically get information. So we had more trust in TinEye than it deserved. So we ended up using multiple services like Google image searching as well. Same thing with the so, say for example, with Webalizer, the nice thing about Webalizer is that it will tell us about the technology running on a certain website or a domain, right? But the nice thing about Webalizer is that if it doesn't have the information right now, they will put it in a queue, and there's a callback URL that they will come back and tell us, hey, we've now updated, so you can now go pull out the list of technology.
Okay, and how long does that take when you submit it till you get the response?
Typically within an hour or two.
Oh, okay. So that could be pretty quick. So I mean, as long as you know what you're looking for. But if you're, I guess the unknown unknowns where you got companies putting stuff up and you're relying on other companies to scan it for you to let you know, that could be more problematic.
Yeah. Another cool thing we're doing is in light of Webalizer and BuiltWith, is that we get a list of technology, right? That's been attributed to a company like Apache Web Server, Grafana, GraphQL, whatever it might be. We get a list of more or less software and products and vendors in play. So we used NIST Common Vulnerability and Enumerations database, the CVE database of NIST. They have a JSON feed of vulnerabilities that are constantly being updated. And we basically look through that JSON feed as it's being updated for any mention of keywords surrounding the technology that are affecting our customers. So, for example, on Tuesday, now actually Monday there was a new vulnerability for Grafana. One of our customers, they have several Grafana instances out there, and we wanted to know if they were vulnerable to this CVE or not. So we took the CVE, take a look at the version numbers, compared with our customer. We tried to develop a proof of concept. We couldn't verify that we could actually hack our Grafana instance. It was a critical vulnerability for Grafana. We couldn't verify because we didn't really know. So what we did is within 30 minutes, we have a Docker container running Grafana with a versionable version, with a configuration that is vulnerable. We have the CVE proof of concept ready, done. We can confirm that this is actually a vulnerability. We can see it. And we apply that same proof of concept to our customer, and they weren't vulnerable. They did not have that vulnerability, even if they were running a vulnerable version of Grafana. And the reason why they weren't vulnerable was because they didn't use a feature called snapshots of dashboards within Grafana. Now, the beautiful thing here now is that we can tell our customer, hey, you should probably patch, but you don't have to patch today. You don't have to patch during the weekend. You can probably wait a while because you are not using this feature that makes you vulnerable to this certain exploit and this certain vulnerability. And that's very useful intelligence for your customers. Instead of having like the flow of alerts and events all the time, we can tell them, this is how we hack you. This is how we can't hack you here yet, but we might in the future.
That's really good information. A lot of times you look for just yes or no, like you can or you can't. This way it gives you a little background information, then you can kind of prioritize the patching of it, which is really useful.
Yeah, because another thing that we're doing is vulnerability scanning. So you can look at us as we will buy those licenses for say Tenable, Nessus, and Nexpose from Rapid7 and so on. We'll get those licenses and we'll use those systems to scan our customers, but we won't necessarily. So what we do is we look at the delta from one scan to another. As an asset changes, that's the keyword. From one iteration to another, what changed? With that information, the pen testing team will look at that information and say, how do we now hack our customer? And that becomes now, the vulnerability scanning becomes much more actionable. It becomes much more applicable instead of, just another alert, just another vulnerability, and you're not certain if you need to fix this or not.
Yeah, definitely. All right, let's pivot a bit to reverse image searching, right? Because I mean, in the past when I played with this, when I would compare things like Yandex or Bing and Google, I guess the three popular reverse image searches, there was drastically different results. And then you mentioned you're using TinEye as well. do you have any tips on how to get better results to find your target with reverse image searching?
So what we are doing is that we are asking our customer for the source material. So they'll send us like a zip file containing like the original imagery and so on. And I mean, the results are varying. It's a decent technique, but it's not foolproof. It's not perfect. It gives us assets in some cases. In some cases, we even identified phishing websites with this technique, but it's not foolproof. What I've seen that works seems to be when you have imagery that are easily recognizable. You know, they're very distinct. So, for example, if you have a company logo, which is not very generic, that will help. If you have like imagery that is like, say, for example, for a ship, that's going to have a lot of false positives because there's ships left and right. So you want to have something that is distinct, I would say.
Okay, yeah, that's good. Yeah, because I've seen also very, like I mentioned, just varied. Like sometimes Bing would be a clear winner, other times Yandex, but it was never like, it really depended on the image. There was never a single search engine that returned really good results each time.
I mean, this technique really shines when you automate it. When you look at the delta from one scan to another, and you only look at what was added to the result set, then it becomes a bit easier to like see if there's something changing that you need to be picking up on. So say, for example, one scan with a reverse image on Bing, for example, say it gives you 5,000 results. You click through maybe the top 20 first pages to see if there's something interesting, but then you automate that search so that 10,000 results, all of those become verified, so to speak. You don't want to see them again. You only want to see what was added to the next iteration, the next scan. That becomes powerful then.
Okay, and then you also cuts down the amount of work you need to do.
Yeah.
Cool. Awesome. All right. Anything else that we haven't talked about that we should bring up?
No, personally, I think pen testing is kind of like a legacy idea. Pen testing once a year. We need to be playing the same game as our threat actors. And the threat actors are always on. They're always looking. There's a beautiful talk from the previous chief tailored access operator. I believe his name is Royce or something. There's a talk on Usenix where basically the NSA's chief tailored access operator, he tells the world how to defend against the baddies, how to defend against threat actors like the NSA. And what it boils down to is having the best reconnaissance, being always on, being persistent, and knowing the target environment. And even Sun Tzu said it from the early days, if you know yourself and you know your enemy, you don't have to fear 1,000 battles. That actually holds true in cyber warfare as well. You can know yourself with asset inventory, and you can know your enemy by just studying attack techniques. And we're living in a world of information. So all the information is out there for us to study. And we can have proof of concepts. There are scanners, open source tools that allows us to do a lot of attacks. And it's a great industry to be in, actually. I love it.
Definitely, yes. And that's a really good point. Just the idea of doing a once a year pen test is really outdated because nowadays the issue is, like you said, it's reconnaissance, it's password reuse, it's the things. It's not necessarily going to be the SQL injection that we used to find left and right. Of course, that's going to be that those are becoming harder to exploit, and many times we don't even need to exploit it when you've got some server that's been left open that hasn't been properly locked down. You can pivot from there, or you guys just password reuse. You don't need to work that hard.
That's the thing, right? Sadly, we work a lot in incident response, and very often our customers are not hacked by super sophisticated hackers. They're hacked via easy to attack web vulnerabilities, things like, for example, password spraying, credential stuffing. And that's what makes Breach Sense so incredibly valuable, that we can now basically be playing on the same field as the attackers.
Awesome. Thanks for the plug. All right, Chris Dale, thanks for coming on the show.
Hey, thanks for having me, man. See you around.
All right, that's it for today. Thanks for joining me every week on the InfoSec and Knowlton Show. And if you're not already subscribed, would love it if you'd smash and like the subscribe button, as my kids say. And I'll be back in your earbuds next Thursday morning.